Chris. So I'm going to turn it over because this will be solved not by me, but by the next generation. Travis, one of our students, is going to talk about the laboratory measurements.
So I do my work on laboratory measurements of directed energy deflection, and laser ablation. And so we have, in our laboratory, we use a basalt sample that is similar in composition to known asteroids with a 40-watt ablation laser. And in our laboratory setup, we use a vacuum chamber to simulate a space environment with a turbo vacuum pump. And during the ablation process, the torsion balance rotates in a horizontal plane, and we then measure the torque caused by laser ablation with a secondary laser that reflects off a mirror, which is fixed to our torsion balance, and that reflection goes into a laser centroid detector, as is shown on the left in our CAD drawing, and we also have a real picture of our vacuum chamber and our sample and the measurement laser. And so we measure thrust versus chamber pressure because the ablation rate is high enough that the turbo pump is saturated. With our lowest pressure to date at approximately 1 millitorr, we get 360 micronewtons of thrust, as shown on the left graph. And a lower limit momentum coupling coefficient of about 45 micronewtons per watt absorbed by the sample. Our laser material models give a thrust of about 100 micronewtons per watt optical, and we have derated this to 60 micronewtons per watt optical to be on the conservative side. And so I would like to show you a video I made of my laser ablation process that was filmed in 60 frames per second at 1080p resolution. So this is a very unique clip because we can see the plume cloud being diffracted by the laser, and we also see sparks coming off. But the plume cloud is very unique in that picture. We also see the laser visible in purple with some sparks in this clip, and we see the very bright spot of the laser on the basalt sample. And so if we look closely here, we also see a plume cloud. We see that bubble almost. And it's very unique, and it just shows the unique environment at the surface of the sample. And so here, this is filmed in a lower exposure, and we can see this is like, we would still be seeing the plume cloud if I was doing it at higher exposure, but this is just to show the bubbling with the ejection plume here. This clip is rather long, so it'll go to a bubbling clip soon. You can see these bubbles happening at the surface. And so here's our final clip, and you see the process of ablation occurring. This is actually filmed at 60 frames per second, so this is real time. Yeah, that's the video. Thank you.